Okay.
Okay. Yeah, I think so.
It's working.
Oh, okay. Yes. Okay. Yeah, everybody hear me? So, hi everybody. My name is Rob Mapes, and I'm with AT&T. And we're going to be presenting some new submissions that build on what Tom just talked about. And luckily enough, I'm not going to have to go through all of the description of all the software that goes into the virtual OLT. So these are hardware-based platforms, and we're going to be presenting three. I'm going to talk about 16-port XGS-PON 1RU virtual OLT, which is a lot of acronyms and words that really describe a pizza box. So if you're in the telco environment, you probably know what a pizza box is. It's not food. But so I'll talk about a 16-port and also a 4-port design. And it essentially builds on Tom's spec that he's already put out. And then Mike Mesh will step up and talk about a micro OLT. And we'll try to get this all done in a half hour. So we've put together a spec, and just what we'll talk about is the general dimensions, environmental compliance, and the main blocks that go into this virtual OLT, which is for PON. If you need to know what XGS-PON is, it's 10 gigabit symmetrical. And that was just consented at the ITT. You may have heard of NG-PON 2, which is tunable optics for ONTs. Very expensive, and we consider that a 10 gig symmetrical PON service is viable economically, not NG-PON 2. So that's what these devices provide. And we'll talk about the PON blocks, the switching device, and these main components were provided to us by Broadcom. And so we had a lot of help in this spec, just like Tom did with his. The other blocks, CPU device, just a simple control FPGA timing block and a PCIe switch. And then we'll talk about the goes into, goes out of, and just to summarize again, it's a 16-port XGS 10 by 10 symmetrical box. We'll talk a little about the traffic and the estimated power budget. So this is sort of what it looks like. This was an earlier prototype. I think this is the Maple 1 chip, which and it does actually 10 gigabit EPON. We're not going to deploy EPON, so don't get scared. It's not that it's a bad technology. You should say we're a telco, not a cable technology. So we might as well just get right into it. What the board that would go into a box like that, a pizza box. This particular one has 16 XFP slots, which can fit on the front faceplate. And also, so you've got the 16 inputs, and then you'll have 4 QSFP28s that sit in the middle of this device. And so what I'm going through is the exact spec that you'll see that'll be posted. And the idea here is exactly what Tom has presented. Any vendor should be able to go to this and build this, either ODMs or OEMs, but they're based on an SoC from Broadcom. And it's the Maple chipset. And the way that this one works is that you can do 2 ports of XGS-PON 10 by 10 out of each chip. So you need 8 blocks for this particular implementation. And then all of the inputs are then aggregated to a QMON, what's known as a QMON switch, the QAX, which can handle 300 gigabits per second in the aggregate, and then provide the upstream links. There are redundant fans and power modules, and then these are the other blocks that we talked about, the timing, the small FPGA, the PCIe switch. And the great news is that you can actually fit 16 QSFPs in the front panel of this device. So for the main blocks, talked about 16 ports. It uses the Maple ECM28258 chip. It's actually what's known as a Maple E0. The chip is expected to be available, I think, with November timeframe, the October timeframe. And then the QAX, QMON switch, is already available. And of course, a total of 6 DDR devices. There's also a small CPU on board. Again, another Broadcom chip. And a small control FPGA. Gives you all the logic for the board itself. There's S2C, LEDs, interrupts, that kind of thing. Timing block, which is key for business services. Could be even esoteric as mobile. That's, again, the key thing about GPON is it supports timing with Amendment 2, and also supports 1 pulse per second options. And then we have a PCIe switch. This kind of looks at the layout of the inputs with the, and this shows QSFP28. There's also room for RJ45s and what have you for user ports for console connections to manage it. And then just some ancillary information basically on redundant power supplies and fans. So that's the 16 port. We also have a submission that's going in for a 4 port. It's pretty much the same components. It's just using less chips. And it's based on the Broadcom suite of SoCs. So this shows sorry about that. So again, the 2 chips, 4 ports. This uses a smaller QAX. It's actually QUX, which is 128 gig, and it's in a much smaller form factor. This would be for remote placement. So remotes, we will have virtualized devices for remotes, and so they'll have to be hardened. They'll more than likely have different powering options. Imagine even putting something like this, which is below 50 watts, in a pedestal. So, scaled down version, and the spec itself lists all the dimensions and all the requirements. And for timing, you're probably going to need a bit interface to bring the timing up to the window. Same sort of components, well documented in the spec. And what's different is it uses a QUX, which is a smaller switch. This kind of shows, and just like in town spec, there's an environmental spec that we include as a document, in the document as Appendix A, which covers the AT&T TV 76208. And that's pretty well synchronization we talked about. And we'll, more than likely need a bits interface. And so that's that. I think we're running out of time for me, so why don't you come up? Mike's going to talk about the innovative concept that we're also submitting a spec for, micro OLT.
All right, so my name is Mike Mesh. I'm with AT&T, and I want to share with you an innovative new design for a XGS micro OLT. So part of our goal with this product, we have 4 items we want to cover. The first off is enabling the NFV layer for PON aggregate for PON access. Second item is disaggregation of software with the existing PON hardware. Third, probably one of the biggest ones, is dramatically lowering cost, power, and footprint for PON. And then, of course, we also want to increase network coverage and decrease time to market. So micro OLT is basically an OLT in an SFP form factor. So this product provides single PON connectivity for any 10 gig SFP plus plug that will plug into either an Ethernet switch or router. The NBN management allows for local as well as remote administration. Low power, high density, hardened device that is applicable for deployment within an outside plant environment. And as both Tom and Robert pointed out, we do have a specification documenting those requirements, TP 76208. I think the goal is to have that posted by the end of the week, so it is a new spec. The MAC integration with the SFP allows for significantly better optical performance. And lastly, the product is built on ITU standards for XGS and NG-PON2. The XGS-PON standard has recently been released. So what I've got diagrammed here, in the center is a traditional PON network architecture. On the right-hand side, you see the next generation architecture where we have disaggregated hardware and software. The micro OLT will plug directly into the Ethernet switch, potentially one that's already existing. By doing this, it eliminates the need for the chassis from the previous middle slide, thus reducing both power and space. All right, so by splitting the PON MAC and optics from the OLT function allows us to deploy remotely, extending the reach outside the central office space. The SFP transceiver with the integrated OLT MAC allows for very small, very modular, low power deployments away from central office in an hardened outside plant environment. All right. So embedded within the OLT, there is a CPU that is both configured and controlled by remote cloud services. Allows it to be deployed anywhere in the network, making it very flexible and reduces overall cost. So the micro OLT is split between a control plane and a data plane, providing a disaggregated solution. Now, within the control plane, you'll see the virtual OLT agent. Now that does communicate northbound with your orchestration layers using netconf yang OpenFlow. And then on the southbound side, it actually will communicate to the micro OLT using the IEEE 1904. So OMCI and OAM messages are transparently passed through the OLT no matter what the destination is, whether it's a micro base station, any type of ONT. The software, as you can see along the top, would be provided by both the ONT vendors, and the micro OLT itself, again, is transparent. Doesn't look at what the traffic is. It will pass regardless of what that vendor is or the application directly through the micro OLT. Micro OLT is a building block component in the virtual OLT platform. It's pluggable, as I said, into any 10 gig SFP plus port that can be switches in a variety of shapes, sizes, formats. It could be in large data centers, central offices, remote hardened switches. The key is that it must be an OSP supported open switch. Termination device can be a home gateway, a business gateway, or base station. All right, so summary. Micro OLT reduces cost by replacing the application-specific hardware that you saw on that previous slide in the center with open compute general-purpose hardware. Allows for flexible architecture, flexible deployment, reduces cost, centralizes equipment, and enables you to reach more subscribers by being able to deploy it within your network. Lastly, it is interoperable and easily upgradable. That's my last slide. Any questions?
Is there a power budget for the SFP bus?
So let me introduce Rich Stanfield from Tidbit. Rich, you want to take that one?
There is a depending upon whether it's at the OLT or the ONT, there is a budget under under 3 watts.
Okay. Any other questions? All right. We finished early, about 5 minutes. So another question, Craig, I'll turn it back over to you.
Okay. So I have a question though, in terms of the submission.
Yes, sir.
Are you submitting a design for the micro OLT?
Yes.
Or is this something that's being produced somewhere else and you want to include it? Wasn't quite clear on that.
So we did produce a submission.
Okay.
So the overall design is what AT&T is backing.
Okay.
We do have, it was contributed also by Tidbit, who produces this form factor.
Okay. Got it.
Okay.
So, and now there'll be a joint submission? Or
It's an AT&T submission.
just an AT&T submission?
Yes.
With the specification?
Yes. And we did, it was provided And so we do have the licensing agreement at the very beginning of the document as well. So,
Okay. Great.
all right.
Michael,
Yes.
the dumb question, I suppose, what's required around that device?
What's required around that device to make everything work? What are the pieces?
So,
Go
so
with it.
basically, it's an SFP plug that would plug into your Ethernet switches. Embedded within the device, the SFP, is basically the MAC and PHY and the optics within this very small form factor. So you basically take your open layer 2 switch, you plug this device in, and that basically enables PON connectivity downstream.
To how many OU?
So it's a single port.
Single one-to-one.
So you may apply a splitter. It just depends on how you want to engineer your network. It could be, 116, 132. We didn't specify that within the submission. All right. Any question? Yes.
The cloud there, is the cloud in the data plane, or is the cloud just the control plane, the OLT software traffic manager?
The cloud is in the control plane.
Just
Yeah. So actually, it's very cool. All right. All right. Anything else? All right. Oh, okay.
I have a question. I think micro OLT is a good idea, but how about the power consumption? One SP module is 1.5 watt,
So
but till now the OLT.
I think that's probably one of the biggest questions that gets asked. In fact, the gentleman over here was asking a very similar question. So, Rich, basically maxing out at less than 3 watts, I think 2.8.
Yeah, 2 watts in an OLT up to 103.
Yeah, so basically what he was saying for the OLT, it maxes out just right under 3 watts for the OLT.
So does that make you a 16-port budget?
I'm sorry, Ted? Question here?
The OLT side, you're looking at density that 3 watts supports the
Yes.
amount of
So,
density.
Within the white paper, there are thermals. It shows it in a 16-port open switch. So yes, it will meet that power budget. Yes, sir.
Not try to beat the thing to the death. The gentleman mentioned that actually the maximum power for SFP plug is 1.5 watts, which is an MSA number. So if you have a 2 point something or 3 watts SFP, when you plug it in, how would you call it?
Chris, you want to answer that one?
We're dissipating 1.9 to 1.9 watts inside the cage. I can talk to you about it afterwards.
So I think we're just about out of time. We're right at the top of the hour, unless there's something, my last quick question. All right.
okay.
So Rich and I will be around outside if anybody has any additional questions.
Thank you very much.